instead of doing our usual Joe Powder sort of thing where we take your questions and we answer them on the podcast, we're going to flip it around this time and actually do the question asking ourselves. I guess you call it Nathan Powder asks Powder people things about powder. So, anyway, I've got Andy Walton here from Keyland Polymers, and he's here to talk about UV curable powder coatings. And yeah, why don't you introduce yourself, Andy? Who the heck are you?
Sure thing, sure thing. So, I'm Andy Walton with Keyland Polymer and DVUV. I've been with the company now for over 10 years and working to promote UV curable powder coatings. So we do a lot of work, and I'm sure we'll talk about it in more detail. But we do a lot of work on interesting substrates. We're not the average powder coating company, and we're happy to be talking with you. So thank you.
Awesome. Thanks. So yeah, I guess for starters, what exactly, what's UV curable powder coating?
So UV curable powder coating cures with ultraviolet light energy instead of thermal heat energy. The cross-linking mechanism for the material is the light. And in order for it to properly cure with light, what we need to do is prepare it. So an easy way to think about it is there's a separation between the melt and flow stages of a powder coating and the curing stage. And what we do with UV is we very quickly melt and flow and then immediately expose to UV light for the cross-linking.
That's really cool. So, what are the benefits of curing with UV instead of, the traditional way?
Sure. Well, the first is that it's much faster. We shrink the time down dramatically. The process itself can be quite quick in that we're only melting and flowing for 1 to 3 minutes and then instantly curing. So it's significantly faster. That's one. A second is we're operating at a much lower temperature. Because there still is heat in that melt stage, we need to get the powder from a powder to a molten state before it's ready to cross-link and cure.
Mm-hmm.
So there still is some heat, but it's dramatically lessens for a much shorter time. And then lastly is the physical footprint of these UV systems. They tend to be much smaller. You can, as a rule of thumb, you can imagine removing about 80% of your traditional cure oven and replacing it with some sort of UV chamber. So they're much more compact in their physical footprint. And all three of these things have some pretty interesting economics in terms of their ability to reduce costs. I mean, we see some pretty compelling cases where we're able to really help businesses reduce their cost of coating.
Right. Yeah. Instead of having to hold the part at a temperature for 10, 20, 45 minutes or whatever, you just smack it with some light and let it cure.
Exactly. It's pretty fun. When we start to talk to people about the technology, we get everything from can I just put it out in the sun to will the nail art curing lamps work. And we do need a pretty intense form of UV energy. The traditional has been microwave lamps. Microwave UV lamps. They put out a very broad spectrum, but the new LEDs are certainly starting to change that industry and become more powerful. So,
well, yeah, and people are probably familiar with UV. Like you said, the nail polish things. There's dental application. I guess they use UV for that, and then there's some like liquid types of things too. But it seems like powder's a little bit more of an oddball when it comes to curing like that.
that's for sure.
But so yeah, how does it compare to a low temperature cure thermoset? People are probably accustomed to, you can go fairly low in temperature with some of the thermoset powder coatings that are out there.
Yes, yeah. That it's really very true. In terms of their their temperature for the flow stage, UV powders still are much lower. We're looking at about 245, 250 F for anywhere from a minute to 3 minutes for that flow. So they're very quick from the flow, and then the UV cure obviously is almost instantaneous. When you compare them on a per pound basis, certainly from a cost perspective, the new ultra low bake powders tend to actually be a little bit more expensive than UV curables. So we're in a place where we're not offering commodity type of powder coats,
Sure.
but we're competing with these ultra low, and we see we're offering a pretty compelling case from a price perspective. And in terms of performance, they're going to be very similar to the low bake powder coats.
Okay. Yeah. So, what are some of the more common applications where you would see, recommend using UV cure powder?
Yeah, we do a lot of the not traditional substrates. We do a lot of work on plastics and composites. Carbon fiber certainly is a big one for us. We do a fair amount of work in the automotive and aerospace industry on that material, as well as recreation. A lot of sporting equipment is carbon fiber and composite now, so we do some work in that area also. Plastic is a big one. And our company really grew out of our sister company called DVUV, where they specialize in powder coating MDF, medium density fiberboard. So there's a lot of applications for MDF, engineered woods, as well as some research and development we're doing on solid wood products. But in the MDF world, we do a lot of cabinetry, healthcare components, ergonomic desking, and retail store fixtures is another big area where we work in that industry. So in general, I would say it's materials that you couldn't traditionally powder coat.
Right.
The type of products like plastics and composites, as well as woods. We do finishes for metal, both ferrous and non-ferrous metals as well. But most of our work tends to be on heat sensitive products.
Well, I guess that's my next question. Is you're talking a lot about composites and wood products and plastics and stuff like that. I know people that are accustomed to powder coatings know, you take your metal part, you give it a good ground, and you hit it with electrostatics, and statically charged powder loves to find a ground, and so it's pretty simple. Like, how do you go about coating carbon fiber, or these wood products that you're talking about?
Yeah, so oftentimes with MDF wood, really the secret is, we like to joke and say magic and fairy dust, but that's not really true. It's use of conductive primers for some of the really non-conductive products, and they can be embedded, and certainly in the plastics, they can be embedded into the plastic themselves, but that tends to be quite expensive. So a lot of the work that we do, we will use a conductive primer as a pre-step. Now, it's not needed for MDF, because for MDF, we'll use that inherent moisture content in the board as a preheat step. But on plastics and some composites, we'll use them. And they're essentially electrolyte and carbon solutions that they can either be water-based, alcohol-based, or solvent-based. And we tend to shy away from the solvent-based products because we like to be a greener technology.
Right.
But they help to establish a ground on the part, and for some products it lasts longer than others. But we see very good levels of adhesion after using them, and very consistent coverage from a powder perspective. So we see really good performance with them.
Okay, so you basically just make the surface conductive, and then you can spray it just like you do with with a traditional metallic substrate.
Exactly.
Pretty cool stuff. So would you say you're able to get the same finish as a thermoset? Like, I'm thinking really clear coats. Can you get super low gloss, special effects, all the same range of colors, or is it? Would you say it's more limited in that sort of?
It's, for the most part, we can achieve most of the standard type of powder coat finishes. There are some exceptions. If you're looking for a really chrome-like finish, that's not a UV powder.
Right.
We have some limitations, certainly in the amount of metallic we can add to the formulations. If we add too much, it tends to interfere with the UV light, and it doesn't allow for really proper curing and cross-linking. So we can make these finishes, but we have to look at them a little bit from a different perspective. The same thing goes with very matte and gloss finishes. We have to add some matting agents because we can't go about it the traditional way, or excuse me, not the traditional way. We can't go about it the same way that a thermally cured powder coat manufacturer does,
Right.
by adding multiple or combining multiple resins.
Yeah, you can't do
So
differential cure when you're curing it in a second.
exactly. So we need to use more different types of additives to get there. But for the most part, we can accommodate some pretty distinctive finishes, and don't have a real difficulty. But again, we're not going to be that chrome-like finish. That's not, at this point, that's not a UV powder. But clears are certainly no problem. So yeah.
Cool. What about like interior, exterior grade? Like, are you able to, you know, get UV durability, I guess, with a UV curable powder?
Yes, you can. So, but to take a step back, all of the commercially available UV solid resins are primarily designed for interior applications at this point.
Okay.
So that's why actually last year in 2019, we started a company called Keyland Polymer UV Resin Spain, where we're doing research and development and manufacturing of these UV cure solid resins, because there's nobody out there that's pushing the envelope with them. So we decided to do it, and
That's
we have some pretty neat resins in development that we hope, certainly with everything that's going on in the world, we can still hopefully have them available Q1 of 2021. So we're pretty optimistic about them, but um, they're certainly specialty materials, and hopefully with the advance in these resins, we can offer more durable exterior type of coatings.
and yeah, that's almost seems like the next logical step. You guys, manufacture the powder and you apply it. So why don't you, make the resins too, and maybe, install the fixtures when you're done with it. Just, you know, all of like I don't know what they call it, cradle to grave, or it's like the entire stack of the supply chain there.
Yeah, we definitely believe in vertical integration. For a while too, we took on the task thinking that we could do systems integration,
Yeah.
but we don't do that anymore. We fooled ourselves with that one. So, but the resin manufacturing and development is something that we're pretty excited to do, and the team we have in Spain, as well as my associates that work in Cleveland, working together, we're really making some great progress on UV curable solid resins.
And that's I actually had a question lined up I wanted to ask about raw materials. Like, I know you're more of the, business development side of things. Maybe it's more of a technical question, but um, there's this analogy that Kevin always likes to use where talks about the formulating toolkit that we have. Like, if we want to make a thermoset coating that's, got any kind of properties, you figure, the toolbox we have to use is like the NASCAR garage with the snap-on, like wall-to-wall toolboxes, and we can like pick and choose all these different materials. If we want to make a UV curable powder, it's like, it's like more like the stocking stuffer, like a hammer and a pair of pliers, and like, that's the toolkit that we have to use. So, do you think that there's, yeah, like what's up with the lack of raw materials that are available? Do you think that there's not enough powder producers that are asking for those sort of materials? Do you think that it would be more common to, um, would we see more UV if the resin companies and the raw material people were pushing it more, or?
That's it's a good question. What we see from a resin manufacturing perspective is that the products that go into these resins are very readily available. The building blocks of the resin, that's very readily available commercial products. The combining of them does take a little bit more time when we make a UV curable resin. It does take more time than making a thermally cured resin. But from a per pound perspective, though, too, it's still a very compelling case. The specialty additives for specialty coatings, some of them don't work because we are not melting and flowing for a long enough time or a long enough or high enough temperature, excuse me. And those tend to be problematic if they won't function in our very tight flow window. So we need to make sure that there are specialty additives that will work within our parameters. And we were talking about a little bit before, there are some limitations that we have, certainly in terms of metallics and in terms of very matte textures. But for the most part, the additives are out there. And certainly from a resin perspective, it's no different than making a thermal product.
Yeah, and I just kind of on the flip side of that, my experience has been with UV cure. It seems like there's some raw material companies out there that focus on liquid type formulations, and they've got a lot, like, huge catalog with 1,000 different things that can be used in UV curable liquid. And so, like, I've found I can look through that list and pick out, like, 3 or 4 things that I'm like, that's solid room temperature. That melts in, the same kind of range that we use. So it's like, yeah, it's like kind of from both sides. Like, yeah, sometimes you can find materials that don't say used in powder coatings, and find a way to incorporate it.
Yeah.
All right. So, what sort of barriers are there for a coder that might be interested in UV curing? Is it like, Joe's job shop that does motorcycle wheels? Do you think that it's the sort of thing that people would want to look into? Like, maybe I should get a UV curing line.
Sure. Yeah, that's a great question, and one we often get, because it's not our goal to convert a traditional thermal cure powder coat line to UV. What we're looking more to do is to take a coat of product that you couldn't traditionally powder coat, bring all the advantages you have with powder coating, the ability to reclaim, the efficiency, and bring that to product that you couldn't traditionally powder coat, products that you would have to liquid coat. That's where we see a real true advantage for UV powders. And it's not really our business to go in and change a custom coater, because we don't really feel that it's a effective proposition, because it's a line of sight cure. And I think that's one thing that a lot of people understand. If the part geometry is such that light is going to cast a shadow on a part, that area in shadow is not going to correctly cure.
Right.
And that can be problematic for a custom coater who is running a variety of different parts. Certainly setting up these lines takes time. And what we found to have more success is to have, a relatively consistent part shape and size. It's not to say we can't cure complex parts. We were able to cure some very complex parts with either rotating the part or putting the lamp on a UV arm. So you can cure very complex parts with UV powder, but it's the scale of the projects tend to not be as great a fit for that custom coater sort of job shop. So we work more with an OEM or a coating company that might coat for 1 or 2 type of vendors or customers.
Sure, like lots and lots of similar parts instead of yeah, like, hey, can you do my valve covers and my my whatever, couple other
Yeah.
odds and ends.
And I'm sure a lot of powder formulation folks get those questions because everybody loves powder coating. And I think certainly in the custom automotive market, there's a lot of work being done, and it looks great. I watch the TV shows where you see it, and it looks really cool, and people have an understanding of powder, and as soon as that light bulb goes off in their mind that, oh wait, I have a plastic part, maybe these guys can coat it.
Yeah.
So we get a lot of those inquiries, and unfortunately we're not a fit for them at this point. Maybe in the future, but not right now.
But I mean, I guess, so you guys are more interested in expanding the powder coating market, coating things that are not traditionally powder coated, as opposed to, replacing existing powder coating as much.
Exactly. That's what we're looking to do.
And I guess on that same note, like, why do you think it hasn't grown, like, to be so much bigger of a portion of the market? I know that there have been kind of these bursts of innovation when it comes to UV powder coating. Sorry, this guy's all up in my face. But so yeah, like in the '90s, they had the electric motors. I think that was the first one. It was like the fully assembled. There was metal motors, but they didn't want to bake the crap out of it in an oven. So yeah, why do you think it just hasn't taken hold quite as much as, like, we think it should?
It's been a consistent adoption of the technology. I think that it certainly hasn't grown at the rate that that we would like as UV powder manufacturers, but it's consistently growing. And we think a lot of the limitation comes back to really the resin level too, because there isn't the ability to do some more robust resins. So that's why the development of us for the resins is really a critical piece that hopefully we can offer a brighter. Let me pause and take a step back. Hopefully we can offer a broader portfolio of resins to meet more needs for the powder coating market.
Is that the plan then? You guys are going to have a whole line of different resins, and you're also going to make it available. Like, it's not just going to be an in-house Keyland Polymer resin, but like, you're going to make it available to the market.
Right. So for the U.S., we'll plan on using these resins in Keyland Polymer powders, and for the rest of the world, what we're looking to do is to position it so we're selling resins. The portfolio right now, it's polyester. We're looking at some super durable polyesters and also some urethanes. So the development of these materials will be pretty exciting for us.
That's cool. And yeah, what other sort of advancements are there, in UV cured technology you guys, have observed?
Yeah, so certainly the big ones are the resins. There is a lot of advancement going on from UV LED, and we see that as a great technology because previously what we were discussing is that the traditional way of curing a thick UV powder was to use a microwave UV lamp, which puts out a very broad spectrum of UV energy. The LEDs put out a very narrow spectrum, sometimes even just a single wavelength. So it's a little bit of a different approach. But what we see from the LED manufacturers is that they are consistently getting more and more powerful, and we can effectively cure at a targeted wavelength UV curable powder coatings with UV LED. So we do see it, and we see that that's a great market because they're lower there's a lower cost to operate them, and they can be instant on and off. So there's a pretty compelling case for the use of LED. I mean, you think about it in your house. I've replaced a ton of my light bulbs with LED, even though I still love incandescent. but LED is really taking over. So
Yeah, that's pretty cool. And so it's just a matter of matching the right photo initiator with that single wavelength, right? Like those
correct.
materials are all available.
From what we see, yeah, we don't have an issue with it.
Okay, that's pretty cool. Are you guys working on any cool new projects that you want to tell us about, or?
We see a lot of interest in certainly in carbon fiber and plastics. We can't talk about it unfortunately in too much detail, but certainly in the automotive and aerospace, there's a lot of interest in these lightweighting materials
Yeah.
and durable finishes for them. So we're getting a lot of interest in those areas, and we're pretty excited to be working in them. They're very different than markets that we previously served, but they're exciting markets to be in. Unique finishes on unique substrates.
Yeah, they're trying to take all the weight out that they can, make everything more efficient, and yeah, powder coatings are so attractive because of the environmental aspect, especially where it's you don't have a lot of solvents and all that stuff involved. It seems like a perfect match.
Exactly.
So yeah, if people want to find out more about Keyland DVUV, like where can we find you?
Well, certainly the easiest way is through the website. So Keyland is keylandpolymer.com, and DVUV is dvuv.com. Delta Victor Uniform Victor sometimes helps. It's a little bit of a tongue twister.
Yeah.
And then our YouTube pages have some good videos and overview of UV curable powder coatings. Okay. So those are some good areas to check us out. And
that link is below. Subscribe.
Yes.
But okay, and then Keyland Polymer Resins.com and Keyland the sawmill that makes MDF.com.
I don't know if we're going to get in the MDF business. That's a difficult one. That would be a difficult one to a little bit capital intensive, I would think. But yeah, the Keyland Polymer has it breaks the sites out for the powder and the resin. So that's a good spot to everything. Exactly. Yeah.
Cool.
Yeah.
Well, that's all I have.
Cool.
So, yeah, it's been fun talking with you, man.
This went well. I hope there's not too many ums in there.
Yeah. Yeah, I'll probably I'll just chop it right around there, I guess. So, yeah, that worked well.
Awesome.
My cat only harassed me for like a third of it, so.
Well, that'll shoot the viewership right up. Is that an orange tabby?
Yeah. His name's Jordy.
Oh, that's cool.
Do you guys do a lot of setting up the whole process and then doing the trials at a facilities, that sort of thing?
Well, we stay pretty involved along the whole process.
Babysit it as it gets along.
Yes, because and what I alluded to before in that one answer when we thought we got into system integration, how badly that failed us. What we have found though is if we don't stay involved, a lot of the integrators don't really know how to properly work with UV curable powder coatings, and the systems don't really get set up in a way that do the best for the coating. So we like to stay involved, and oftentimes too, we're the first people that the customer contacts. They contact us first, and then start branching out and talking to integrators and pretreatment folks and that sort of thing. So we tend to hold their hand all the way through, which has worked quite well. But sometimes I am hopeful for the day where we can just somebody orders powder and we send it, not even asking what they're going to do with it.
Yeah,
but we're not there yet.
Like it has to be a custom installation every time because it's going to be new to everyone that does it. You don't really have, that normal UV customer that just like, okay, I need to order a bunch of different UV stuff. So.
Right, right. I mean, we certainly have repeat. I mean, almost all of our business is repeat customers, but yeah, it's not it's growing, but it's not there yet. So, have you guys been working with a good amount of UV?
Not recently. Um, we've had it's like we'll have a really big, one that we work on for, a year, and then it may or may not work out, and then we won't hear about UV for a little while.
Yeah.
The last one, I don't know if we talked to you guys about it at all, but it was a real low temp. It was like a foam core kind of building materials. You figured like baseboards, trim parts, that
Oh
sort of
yeah,
stuff.
yeah.
And that stuff was like you just touched it with any kind of heat, and it would just it'd deform, and it's like
Yeah.
it's like trying to coat styrofoam. So it's like if you're gonna do a powder coating on it, then like UV is the only way to do it. But even then, it was real tough to get any kind of adhesion to it. Adhesion's always the biggest problem. I should have had a question in there because, man, that's the one, like UV cure on weird substrates problem that always rears its ugly head is
Oh yeah.
like, all right, it looks really nice and the gloss is right and the color's right, but it does not like to stick.
Yeah, well, that's something I actually was supposed to talk about too. So I don't know, maybe if we, after all this all gets digested, if we need more or something. But we've been doing a lot of work with plasma,
Yeah.
and we see that certainly with very slippery material, it is amazing. But sometimes it doesn't even last long enough for coating. So we've been working a lot with that. There's a project, a carbon fiber project that we're working on that we're using conductor primers and plasma. And it's like, okay, this is a lot of steps to get to a UV powder, but
Or
you can't coat it any other way. So
we're
it's
shrinking
a
the
good fit.
footprint and then we're expanding it again.
Yeah, at the same time.
But that plasma stuff was so cool. We had one of their units in the lab for a while, and
Oh, cool.
Was it polyolefins? It's like it was like, hey, now we can get stuff to stick to it, which you
Yes.
cannot get anything to stick to it normally.
Terrible. Terrible. Yeah.
Yeah.
Well, thank you again. I appreciate it. This is fun, and if anything comes up in terms of questions or I should re-answer something or give us a listen, I'm flexible to do that. So
Yeah, sure. And like I said, I don't know if the video will ever see the light of day. Like maybe the cattle help out the help get us some subscribers.
Thanks for letting us be your guinea pig for this. This is fun.
Yeah, man. I like the idea of doing this sort of thing. Like talk to equipment people and pre-treatment people, and like Joe's job shop that does motorcycle wheels. Like
exactly. Well, and I think that sorry to interrupt you, but I think that the column that Kevin writes really has a it gets that combination of technical and not technical questions, and it's like a trusted resource for a lot of people. So I think that's I think that's a big reason for me that the podcast is interesting, because it's there's a integrity behind it that and like I've listened to some other business podcasts and you're just like, oh my God, like this is terrible. So I think that also makes it a lot of fun, and hopefully it is something. I know when we had our conference call, it was like, we don't know how long we're going to do it. Well, hopefully it's beneficial, and you keep on doing it, because I think it's pretty cool.
And it's fun, and it's not like it saps up a whole lot of resources. Like he's got 15 years of questions that he could read. Like, we don't have to, I'd love to have people actually call in. Like, we keep trying to pump the phone number and say, hey, like, if somebody could call in, leave a voice message, then we could chop it into the podcast. That'd be a good way to, to incorporate that. But like, for now, it's like, yeah, he has 500 questions that he's answered for Ask Joe Powder in magazines, and
Right.
so we can just say, hey, let's do one about one about craters and one about raw materials, and it's like, yeah, like, you just, I don't know, I think there's enough out there that, yeah, it's not going to drag on us so much that we're like, God, like, maybe we should stop doing this. So, yeah, man.
Cool.
Well, I guess I'll let you go. And
sounds like a plan. Yeah. Enjoy the rest of your Friday, and thanks for doing this.
all right. Have a good one.
All right. You too. Take care.